Hello everybody. In this video we're going to go through integration by parts circular method. We're going to do two famous examples. Integration by parts formula is u times v minus integral of v times du. Let's begin. In our original problem we're going to pick up u and dv. So our e to the x is u and cosine x dx is our dv. So this is our u and this is our dv. Our u is e to the x, so du will be derivative of this, which is e to the x dx. And our dv is cosine x dx. And v will be integral of this, integral of cosine, if you go to counterclockwise, sine x. Now we're going to plug this in integration by parts formula. Our original integral, which is integral e to the x cosine x dx, turns into u times v, which is e to the x sine x, minus integral of v, which is sine x, and du is e to the x dx. So we can write e to the x dx this way. This part of the function is good, however we need again integration by parts. So this is going to be our second integration by parts. So we need u and we need dv. Let e to the x be our u because it's differentiable, and sine x dx be our dv because it's integrable. Then du will be derivative of this, which is e to the x dx, and dv is sine x dx, so we need to take integral of sine x. We have to go one step counterclockwise again. Our v will be negative cosine x. Now we need to plug this in our integration by parts formula. So our original problem, integral of e to the x cosine x dx, turns into e to the x sine x minus, instead of this integral we have second integration by parts, which is u times v, which is e to the x negative cosine x, minus integral of v du. V is negative cosine x. We can pull negative sign here and makes this positive. V du is e to the x dx. Now, if you realize that, here we need another integration by parts. But if you realize that this is our original problem, e to the x cosine x. So we are repeating our original problem. So let's let this integral be I. So we said that this integral is equal to I. Then let's plug in I. So this is going to be I, and this is going to be I. Then I is equal to e to the x sine x, and if we distribute negative sign, it's going to be plus e to the x cosine x minus, this was I, that's what we called. Now we have to merge i's, add I on both sides. So what we have is 2i is equal to e to the x sine x plus e to the x cosine x. We're solving for I, so we can divide both sides on 2. Okay, then I is equal to e to the x sine x plus e to the x cosine x divided by 2. You can leave your answer in this form, or you can simplify a little bit. Then I is equal to, you can pull out e to the x because it's the common factor. So e to the x over 2, or 1/2 e to the x, times sine x plus cosine x. So our original integral is equal to 1/2 times e to the x times sine x plus cosine x. Or you can live in this form. In the integration by parts, you will realize that you're repeating your original problem, then assign a letter for the original problem and solve for that letter. Let's check out another example. Example 2 is e to the x sine x dx. So we're going to integrate this function. Again, let e to the x be our u and sine x dx be our dv. If e to the x is our u, then the u will be derivative of this, which is e to the x dx. And we said our dv is sine x dx. Then our v will be integral of this, integral of sine x. If you go to one step counterclockwise, you get negative cosine x. Now we're going to plug this in integration by parts formula. U times v minus integral of v du. So our original problem, which is integral of e to the x sine x dx, turns into u times v, which is e to the x cosine x, negative, minus integral of v du. Our v is negative cosine x, makes here positive, and du is e to the x dx. Now here we need another integration by parts. So this is going to be our second integration by parts. So we need u and dv. Again, let our e to the x be our u. So du will be derivative of this, e to the x dx. Our dv is cosine x dx. So we pick e to the x as our u and cosine x dx as our dv. So v will be integral of this. Integral of cosine x is sine x. Now we're gonna plug this in integration by parts formula. Our original integral, integral e to the x sine x dx, turns into negative e to the x cosine x plus, instead of this integral, we need to apply again u times v minus v du integral. So u times v is e to the x sine x minus integral of v, which is sine x, du is e to the x dx. This part again requires integration by parts. However, this is our original problem, so we need to assign here some letter. Let this integral be I. So I is equal to negative e to the x cosine x plus e to the x sine x minus I. And if you add I on both sides, you get 2i is equal to negative e to the x cosine x plus e to the x sine x. And if you divide both sides on 2, and if you solve for I here, I will be equal to, and factor out e to the x and 1/2, so negative 1/2 e to the x. So we have cosine x minus sine x. And plus c, let's not forget plus c because it's indefinite integral. Thank you for watching.